Hi once again, this is Bulelani, your lecturer. I want to show you the difference between these two examples, the first one and the second one. Now, on the first one, we do not need to use any substitution for this one, because we can do it without any substitution. But for the second one, we need to use the use substitution. So let me show you what I mean by that. I would also like you to notice that on one side we are deriving, because now we are finding the du over dt, and also we are making dt the subject of the formula, because that is what we have on our original formula. Now, after finding this, it is time for now to start integrating. Then we are integrating u at this point. Remember, the square root will become power of half. Now at this point, we need to find the equivalent of dt. So dt is the same as du over 2, as you can see. So that is what we will have. Our integrand is raised by a half. Now let us start to integrate, because we have finished with our substitution. So how to integrate? You add 1 to your exponent and divide by the new exponent. As we are dividing by 2 is the same as multiplying by a half. Also, notice on this step that the 2 and the 2 will cancel out. Therefore, what are we going to be left with? We'll only be left with that, with the new exponent and the plus c. But it does not end here. We still need to substitute by the value of u, because we have an equivalent for that u. So let's do the substitution. Always keep in mind that when the exponent is a fraction, you need to put the numerator on top of the bracket, and then the denominator will go to that. Don't forget to divide by 3. This is an integration. You must always have plus c. So this is what is known as a function of a function. On the second one, we will be deriving in a different way. This is a perfect square. So how do we deal with a perfect square? You always take the square root of the first term, as you can see me right here, then the sign of the middle term, as you can see me dropping it, and the square root of the last term. That is how we deal with the perfect square. Bearing in mind it's under the square root, but to make it simple, I'll still have it as a perfect square and then integrate on the next step. Otherwise, you didn't have to do that if you wanted. Then when you integrate on the next step, you'll see it is much simpler. The square and the root sign has cancelled out. Now we are starting to integrate. There you have it. T squared over 2 minus t plus c. Simple, straightforward. And there you have it. It's very obvious. We integrated straight ahead without going all the way the long road of substitution and all other stuff. So this is a difference. The other one, you can do it straight ahead without any struggles, but on the second one, you really need to do your substitution to make it simple, so that you can be able to integrate it and it will make sense to you. I can see I'm so used in dealing with x. Now I have to change that. Actually, we're deriving with respect to t. I can keep it as x. So that is the answer, guys. I think it's straightforward. God bless you. At this point, I know you have noticed the difference between those two and how to treat them.